Okay, AP Chemistry class, this is the second part of the Day 14 assignment. This is really the heart and soul of the assignment. It is the balancing chemical equations. You're going to be doing this almost every day throughout this course, and it may come easily to you. It may not come easily to you at first, but keep practicing and you will get it. It's like anything else, you will get it, whether it comes to you quickly or not. So don't get frustrated by this. So what we're simply doing is counting atoms. It's called conservation of mass, but if I have two hydrogen atoms, I have both the same number, and since they have the same mass, I have the same mass of hydrogen atoms. So it's called conservation of mass, but we really think of it as conservation of atoms. And by the way, that word conservation means to keep something the same, to save it or to keep it the same. So what we want is the same number of atoms on the right side of the arrow as on the left side of the arrow. And we define these in class. In the left side of the arrow are called reactants. That's what's reacting in the chemical reaction. And on the right side is what comes out. So you read it just like a sentence from left to right. Okay, so I'm going to show you a couple of methods for doing this. I'm having a little problem with my focus here. Let's see. I don't know if that's going to help, but we'll see if that helps a little bit. Okay. So what do we look at? First thing I would like you to do is down below the arrow, directly below the arrow, wherever that is, you write down what elements you're dealing with. So I have a nitrogen, I have a hydrogen, just two elements. Okay. And what I want to do is count how many atoms I have on each side before I get started. And in order for an equation to be balanced, in order for us to work with that equation, it has to be in balance. So over here I have two nitrogen atoms. I have a nitrogen molecule, and I'm going to draw that for you down here. And I usually draw that, it's covalently bonded, so it's interlocking circles. So those are two nitrogen atoms forming a nitrogen molecule. That's what this 2 means. It's forming a single unit called a molecule. The same is true for hydrogen. And then over here I have an ammonia molecule, so it has an N, and then it has 3 H's. It's also covalently bonded because nitrogen and hydrogen are nonmetals, so it's a covalent bond sharing electrons. Okay, so there we go. That's what we have. Now if we look at it, on this side of the arrow we have 1, 2 nitrogen atoms. We're counting the atoms, not the molecules. So I'm going to put a 2 there. On this side we only have 1. Hydrogen. On this side we have 1, 2 hydrogen atoms, and on this side we have 1, 2, 3 hydrogen atoms. So in order for us to be able to use this chemical equation, we have to have the numbers on this side equal the numbers on that side. And the way we do that is by a series of multiplications of different elements. There's no fixed set of rules to do this. I can't say step 1 do this, step 2, step 3, and so forth. So you're going to have to develop some skill at this, but it will come with time if you'll keep practicing. Okay, so let's go ahead. How are we going to do this? First of all, just pick an element. It doesn't matter where you start in most cases. In some cases it does. In this one it doesn't. I could have picked either nitrogen or hydrogen. I'll actually do this one both ways to show you that. But I'm going to start with nitrogen because the numbers are smaller and they look easier to balance. So I have 2 on this side and 1 on this side. And remember, everything you're doing here are multiplications. So if I need them to be equal, I can't do division, but I'm allowed to do multiplication. I'm going to multiply this by 2. So 2 times 1 is 2. That means they'll equal each other. So what I'm going to do is come over here. You can't put the 2 there. That's the subscript. You're not allowed to change that when you do balancing. You're only allowed to change the number in front called the coefficient. So what I said is I need 2 nitrogen, so I'm going to put a 2 right there. The reason I'm writing it up here is that might not be my final number when I get the equation finally balanced. So I want to just put it up there to keep it out of the way. So now what I have is 2 of this entire molecule. So I'm actually going to draw this entire molecule a second time. I didn't just make 2 nitrogens, I also affected the hydrogens that are there, and I doubled all of those. So now I have 2 ammonia molecules, but what it does have is what I was shooting for, which is 2 nitrogens. So I have 2 nitrogens there, and over on this side I have 2 nitrogens. So nitrogen is now in balance. Okay. Now, what about hydrogen? Well, now what I did after I doubled this, I have 1, 2, 3, 4, 5, 6 hydrogens, and over here I have 1, 2 hydrogens. Again, I need those 2 numbers to be equal. I'm not allowed to divide. I am allowed to multiply. So what I do with a 2 to make it become a 6? What kind of multiplication? And yes, that's going to be a 3. Okay? So now I have 3 of these hydrogen molecules, each of which has 2 atoms in it. Okay, so let's count. Let's see if everything's even now. 2 nitrogens, 2 nitrogens, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6. Everybody's in balance, so I'm going to write that over here. So nitrogens, I have 2 and 2. Hydrogens, I have 6 and 6. Everything's in balance. I counted them. So now I can go ahead and put these numbers down here. So this is a 1, this is a 3, this is a 2. And go ahead and write coefficients of 1. Even though typically you don't do that in chemistry, I want you to see that this is a 3 to 1 and a 2 to 1 relationship. So there, we've balanced our equation. Now I'm going to show you, what if I had decided to start with the hydrogen rather than with the nitrogen? Could I have done that? So let me quickly write the equation again. And I have N2 plus H2. Always remember when you're writing out an equation, to leave a space for the coefficients. I usually draw an underline to be sure I give myself enough space to write the coefficients. Okay, so again, let's draw what we have, particulate model. Whenever you draw little stick figures of atoms and molecules like this, little circles, and I'm sorry, that should be H2. Erase it. Whenever you have these little stick figures, that is a 2. Like this, that's called a particulate model, and you're going to do a lot of these in class. Okay, and I messed up. This is N2. Talking and I'm not thinking. So you got 2 nitrogens, 2 hydrogens, and now again you have the okay, and then you have your ammonia, and that's a nitrogen in the middle there. Okay, what if I decided, last time I started with nitrogen, what if I started with hydrogen? Well, that's a little bit messy, and here's why. So you want to sometimes, it doesn't matter where you start, but starting in some places is better than starting in other places. So if I decided to start with hydrogen, I have 3 hydrogens here and 2 here. So now what I have to find is a least common multiple of those 2 numbers, the smallest number that they both multiply into evenly. And that number would be 6. 2 goes into 6 3 times, and 3 goes into 6 2 times. They have to go in evenly. So that means up here I'm going to have to put a 2. I'm going to have to create another one of these guys, ammonia. And I'm going to have to create, so now I have 6 hydrogens, and now I'm going to need 6 hydrogens here. So I'm going to create and yes, please do these in pencil. So now I have 6 hydrogens, 6 hydrogens. That means I had to multiply this one by 3. And my nitrogens are now in balance. It just so happens, without even trying, I ended up with 2 nitrogens, 2 nitrogens. So again, I end up with the same balance. I just did it a different way. So my point is simply, it doesn't always matter where you start, but there are times when it does. And again, that's just experience of understanding when it is, which it is. Now I'm going to show you a model that a lot of teachers use. You might even find it on YouTube somewhere. It's called the box method. It's very similar to what we did right here with the particulate method. And it really is almost identical, although it looks a little bit different. So here we go. I'm going to do this one more time. Okay, so what we're going to do is we're going to draw a box below the element right here. First of all, always draw a line down the middle so you know which side is which of the arrow, because you want this side to equal this side. So it's almost like your equal sign. So I'm going to draw a box below this, and in it I'm going to draw the two nitrogen atoms. Don't draw N2, just draw N and N. Those are the two atoms in nitrogen. I'm going to do the same with hydrogen. And I got H and H. And over here, I'm going to draw a little bit bigger box because I got more things to fit in there. I have the N and the H, so I'm breaking it up into its individual atoms here, N and H. So you can see here 2 nitrogens, 2 hydrogens, a nitrogen, and 3 hydrogens. Okay? All right, so what I got to do is I want to keep drawing boxes until everything is equal. And you always draw the box where you have the least of a particular element you're trying to balance. Okay, so if I look here, we'll start with nitrogen again. I have 2 nitrogens and 1 over on this side of the equal sign. So what I'm going to do is draw another box, the entire box. It has to be a perfect copy of the one above. You can't just take parts of it out. So I'm going to draw, and notice that's similar to what I was doing up here with drawing another ammonia molecule. So now my nitrogens are in balance. Okay, so I have 2 N's here and I have 2 N's there. Now hydrogen. So I have 2 here and I have 1, 2, 3, 4, 4, 5, 6 here. So I need to get this to be up to 6. So I draw another box. And now I have 6 hydrogens here. I have 2 nitrogens here, and now I simply fill in my coefficients by counting the boxes. I have 1 box here, I have 1, 2, 3 boxes here, and I have 1, 2 boxes there, and that gets us to the same end that we had before. So it really is very much like the particulate model. One thing I like about doing it this way, is the particulate way, is that's what the AP is going to want to see you do, is be able to draw particulate diagrams, just these little simplistic diagrams of atoms and molecules. Okay, so now we have another reaction here that we're going to balance. I'll just throw out some names. This is a decomposition reaction, meaning you're taking a compound and breaking it up into 2 different things, 2 or more different either compounds or elements. We'll get into the names of these types of reactions very shortly. Okay, so here we go. What we want to do is, and I'd like you to get in the habit of doing this first, is write how many of each element you have on each side. So what we have actually, and I should have drawn the line there. Is what we have is we have K, we have Cl, careful, it's not Ci, it is a Cl, which means it's chlorine, and then we have oxygen. And I look on this side, and those are the only 3 things I have, so good. So we're going to count. So the subscript here is, there's no subscript, that means it's a 1. We have 1 potassium, no subscript there, so we have 1 chlorine, and we have 3 oxygen atoms. Over here we have 1 potassium, 1 chlorine, and we have 2 oxygen atoms. So we notice that potassium and chlorine are already in balance. Oxygen is not. However, in balancing oxygen, we may throw either potassium or chlorine out of balance temporarily until we get to our final answer where everybody's in balance. Okay, so let's go ahead and do this. And this is usually the way I do it. I kind of use this least common multiple method. So 2 and 3 both go evenly into 6. So if I multiply my O2 by 3, I end up with 6 oxygen atoms. Each of these has 2, so let's draw that. So we have O2. And put little O's in there. Now I have 3 of them. Draw them a little bigger. Okay, so I have 3 oxygens. Okay, so over on this side, what do I have? Over on this side, I have, if I'm just looking at oxygen, I have 3, so in order to get to 6, I can go ahead and write this out as a KCl. I'm not going to try to do the shape of this necessarily, but and I've got 3 oxygens like that. Just going to put the KCl together. Okay, and if I want to get to 6, I need to do another one of these. So now I have 6 and 6. So I needed 2 of these entire compounds. I can't just multiply just the oxygen. I needed 2 of these to get my oxygens up to 6. So now I put a 2 there, so 2 times 3 is 6. And 3 times 2 is 6, so my oxygens are in balance. Okay. However, I've thrown my K and my Cl out of balance. I now have 2 potassiums, whereas I only have 1 over here. I have 2 chlorines, whereas I have 1 over here. Well, because they're stuck together, I could go ahead and draw them together. But what do I have to do to balance that? I have to put a 2 here. So now I have 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines. I have 6 oxygens, 6 oxygens. So what I can do over here is I can write that down. I have 2 and 6, and over here I have 2, 2 and 6. So that these match up, this column and this column, so everything is even. So I can go ahead and put a 2 in my final position there. And that is how you do that. Now let me go ahead and do the same problem if you like the box method. Let me do that that way. I'm not going to do every one both ways, but let's go ahead and do it with the box method. And again, it's very similar to this. So you have KClO3. All right, so what I'm going to simply do, not necessarily list elements, I'm just going to go ahead and start drawing boxes. So in this box here, I have K, I have Cl, and I have O, 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 3 O's. You break them up into separate atoms. Over here, K and Cl, and over here, I have O and O. All right, so K and Cl are in balance. There's nothing I need to do to those. Again, I have to draw as many boxes. If I draw this, you always draw the box that has the least number. So I have 2 O's here and 3 O's here. So I'm going to draw 2 more O's. Remember, every time you draw a new box, it has to be a duplicate of the one above it. You can't change it. So now I have 4 O's here and only 3 O's here. So that means I have to draw my box where I have the least number of O's. So now all of a sudden that's over here. So another K, another Cl, O, O, O. All right, so now I look at this, and now my K, I have two K's over here and only 1 here, 2 Cl's, only 1 here, but I don't want to go there right now. I want to finish with the oxygen first. So now I have 6 oxygens on this side and only 4 on this side, so I have to draw another box on the side where I have the least number. In this case, I have 2 on, I had 4 on this side versus 6 on this side. Okay, so now I have 1, 2, 3, 4, 5, 6 oxygens, 1, 2, 3, 4, 5, 6 oxygens, so the oxygens are in balance. Now what about potassium? And you have to do the elements one at a time. I could have picked chlorine, I chose to pick potassium. So I have 2 potassiums, I have 1 here, so this one has the least number, so I add a box of KCl here. It's got to be an exact duplicate of the one above. So now I have 2 potassiums, and now I have 2 potassiums. I noticed that I didn't do anything with oxygen to throw that out of balance. Oxygen's still in balance. And now it just so happens that now I have 2 chlorines and 2 chlorines, so everything's in balance. 2 potassiums, 2 chlorines, and 6 oxygens. So I simply count the boxes. 2, 2, and 3, and there is my balanced equation. Okay? All right. Okay, now we're working with what's called a single replacement reaction. You have sodium chloride, and you're mixing that with fluorine gas. The fluorine gas takes the place of the chlorine and it produces chlorine gas. So one element replaced another. Single replacement reaction. We'll talk about that later. Okay, so what are we going to do? Let's count, let's list our elements. Okay, we have 1 sodium, 1 chlorine, 2 fluorines. We have 1 sodium, 1 fluorine, and 2 chlorines. Alright, sodium's already in balance, so we don't do anything with that. It really doesn't matter whether we pick fluorine or chlorine. So if I have 2 on this side, I'm going to have to multiply this side by 2. So I can't just multiply it. I certainly cannot put a subscript. That's absolutely illegal. So what I'm going to do is put a 2 up here. So what I've actually done is I've doubled the number of sodiums and I've doubled the number of fluorines. So now I have my fluorines are now in balance. I can actually scratch that out if I want and put a little 2 there. Alright, however my sodiums are now out of balance. And that happens. You take things out of balance before you get to the final answer where everything's in balance. Okay, so now what I could do is I can go ahead and balance my sodium. Since I made this into 2 sodiums, I can come over here and make this into 2 sodiums. Now my sodium is back in balance. Na2, there's 2 Nas, 2 Nas. My fluorine is still in balance. I have 2 fluorines and 2 fluorines. And so let's look at chlorine. Let's see if we got lucky and got that in balance automatically. And I have 2 chlorines, and over here I have 2 chlorines. So I don't need any coefficient there. I can put a 1 there, and I can put a 1 in front of the fluorine. Again, you don't have to do that. I tend to do that. I would like you to do that, actually. So you see the mathematical relationships. Okay, so the answer is there's a 2, a 1, a 2, and a 1. Okay, this one, let's use the box method too. Again, if you don't want to do this or don't want to see this, you can skip ahead to the next problem. Or if you only want to see this, I'm not going to do everyone with the box method though. It's just not the way I do it. But if it's your thing, go ahead and do it. Okay, so I have an NaCl. You separate it into the Na and the Cl. Here I have 2 fluorine atoms. You break everything into its atoms. Here I have an Na and an F. And here I have 2 chlorine atoms, Cl, Cl. Okay, let's start with Cl. I have 2 on this side, 1 on this side. So I always add a box to the one that has the least. So I have NaCl. So now chlorine is in balance. How about Na? I have 1 Na here on this side of the arrow. Again, draw a line to be sure you're working on opposite sides of the arrow. I have 1 here and 2 here. That means I have to add the box where I have the least. Okay, so now I have 2 Nas. I have 2 Nas. I didn't do anything to mess up my chlorine, so they're still good. And fluorine. Now I have 2. I got lucky, and usually this happens, by the way. You're not really getting lucky. I have 2 fluorines on this side and 2 on this side, so everybody's in balance. So I have 2 boxes here, 1 box here, 2 boxes here, and 1 box there. Okay, there you go. Not so bad. This stuff is not so bad. Just practice it, practice it. Okay, this next problem, number 4, we're going to make some water from hydrogen gas and oxygen gas. And what we are going to do is we'll use the box method this time. Okay, we'll flip back and forth between those. So what I'm going to do is create a box here with hydrogen and hydrogen, and one here with 2 oxygen atoms, and one here with a water molecule. Excuse me. You break the water molecule into its component atoms, 2H and an O. All right. Our H's are already in balance. Our O's are not. We have 1 there and 2 there. Again, draw a line when you use the box method so you don't get confused with what you're balancing with what. So I always go to the one that has the least number of the elements, so we only have 1 oxygen there. So we have to draw another entire water molecule. Okay. So now I have 2 O's and 2 O's. As far as H's, though, I threw them out of balance. I have 1, 2, 3, 4, and only 1, 2 there, so I go to the one that has the least. That's 2. And I have to add another one of these. And now I have 4 hydrogens, 2 oxygens, 2 oxygens, Everything's in balance. 2 boxes, 1 box, 2 boxes, and bam, you're done. Okay? All right. Okay, so let's go ahead and we're going to list our elements. And we have underneath, we have Pb is lead, we have oxygen, we have hydrogen, we have chlorine. We have another hydrogen there, but that's the same as hydrogen, chlorine. Let's count atoms. Okay, I want to do it this way because I want you to make sure you're clear on how many atoms you have of each. So lead, the 2 does not apply to the lead. It only applies to what's inside of the parentheses here. So this hydroxide, it means there's 2 of these hydroxide ions here. So lead, there's only 1 of those. Oxygen over here, we have 2 times, oh, you distribute the 2, so it's O2. So there's 2 of those. Okay. Now over here you have 2 hydrogens. It distributes to that. But you also have a hydrogen there. So that's a total of 3 hydrogens. And finally you have a chlorine right here, so there's 1 of those. We go over to the other side. We have 2 hydrogens, 1 oxygen, 1 lead, and 2 chlorines. Okay, so the first thing I look for is a couple things. You don't want to balance any elements that appear more than once on the same side of an arrow. We don't have any that appear more than once here. We do have hydrogen appearing more than once here. So I would stay away from hydrogen until the very end, and oftentimes it'll find itself in balance. But that's too complicated because in all you have 1, 2, 3 different locations that you have to get the hydrogen in balance. So don't do that. Always try to start with the easiest thing to balance. All right, so what do we have that looks like it's easy to balance? Well, lead is already in balance, so you can't balance that. But oxygen or chlorine look like good candidates, and chlorine looks like the easiest. So what I'm going to do is I have a chlorine here, and I have 2 chlorines over here. So to put those in balance, I have to put a 2 up here. Okay, so now I have 2 HCl. Okay, and so I have 2 HCl. That means I have 2 chlorines, but now I've doubled my number of hydrogens. All right, so my hydrogens are also in balance. So I've got hydrogen and chlorine in balance. So lead, hydrogen, chlorine are in balance. So now the only thing we have, hydrogen is not in balance. I apologize. Hydrogen is not yet in balance because we have 2 over here. All right, so I have 2 hydrogens here and 2 hydrogens here. So that makes 2 hydrogens. This also makes 2 hydrogens. That's a total of 4. So I'm going to put a 2 here. And now I have 2 times 2 is 4. I have 2 times 1 is 2, and 1 times 2 is 2. So 2 hydrogens on that side. That's a total of 4, and 4 hydrogens on this side. Now what we do is let's look at oxygen. When we added the 2 there, we not only doubled the number of hydrogens, but we doubled the number of oxygens. So now we have 2 oxygens. So if we come over here, we notice we already have 2 oxygens. So it looks like everything is in balance pretty much. So let's count. Let's just draw a line here. And I have 1 lead over here. I have 1 lead over here. That never changed. I have 2 oxygens here, and I have 2 times 1, subscript 1 there, the oxygen there. Hydrogen, I have 2 times 1 right there is 2, and 2 times 1 is 2 is 4. And I have over here, I have 2 times 2 is 4. And then finally chlorine, I have 2 times 1 and 1 times 2. So everything's in balance, so I can fill in my numbers. The ones I didn't have to change remain as 1, 2, 2, 1. Okay? Let's do this with the box method. Let's see if it's easier with the box method. I'm doing both. I want you to be able to choose a method that you like. Eventually you'll get to where eventually you'll get to where you're doing these in your head. Okay, and we have HCl here, arrow, water, and lead chloride. Alright, let's see how this, I haven't done this one with the box method, so let's see how it works. Basically, you break everything up. PB. You want to do it in kind of an organized way. Now I have 2 oxygens, and I have 2 hydrogens over here. For HCl, I have H and Cl. Water, I have an H, an O. Lead chloride, I have a Pb and a Cl and another Cl. Okay, where do we start? What do we balance? Let's start with oxygen. I have 1 on this side and 2 on this side, so I'm going to draw another box of water here. Okay. Again, we don't want to try to balance these because they're in 2 different locations there. That makes it kind of tricky. So let's go with the chlorine. I have 1 on this side and 2 on this side. So I'm going to double this. So now I have 2 chlorines there. And lead is already in balance. So let's just double check. Lead is in balance, 1 and 1. Chlorine is in balance, 2 on this side, 2 on that side. Oxygen is in balance, 2 on this side, 2 on that side. And if we look at this, hydrogen, 1, 2, 3, 4, that's on the left side, on the reactant side. And over here, 1, 2, 3, 4. That's on the product side. And there you go, everything's in balance. So just count your boxes. 1, 2, 2, and 1. All right? And there you go. That balanced pretty easily, didn't it? Okay, so this next one's a little bit tougher. What we're going to do is I'm going to show you a little trick here. You have sulfate here, and right there, SO4. You have an SO4 3 times that. If you want, you can treat this as a single element, or as a single element, a single atom, even though it's not an atom, and treat this as 3. I'll probably talk to you more about that later. That's a little bit advanced for what we're doing right now. But again, I'm going to just show you the box method. I think it's the easiest for you to use, even though I don't use it. I think it's a good method to get you started on this. By the way, that should be BR3. And let me just check the rest of mine. And I got it. KBRAL. Blah, blah. Okay, so here we go. We're going to draw our box, and we're going to break everything up. So AL, BR, BR, BR. Okay, over here, can you break everything up into individual atoms? So I have 2 Ks, I have an S, I have 1 S, and I have 4 O's. Come over here, I have a K and a BR. Come over here, and it's going to be a zoo here. I've got 2 ALs. I have 3 times 1. Okay, remember this 3 distributes through. So I have an S, an S, and an S. And this is crazy time. Okay, now I have 12 oxygens because I have inside the parentheses you distribute that 3. 3 times 4 is 12. So I'm going to try to draw that neatly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we've broken everything out. Now we start with the least of something. The easiest one it looks like is aluminum. You have 1 aluminum there and you have 2 there. So I'm going to draw a second box over here where I have the least, where I only have 1. And I am going to write that, and then you got your bromine. Okay? Now, this is where it gets a little crazy here. I have 6 bromines. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I only have 1 on this side. So I'm going to have to draw 6 boxes to get those to balance. I know it's a little bit of drawing. That's why I asked you to do this on line paper and not try to do it where you are on the sheet. Okay, there you go. You got 6 of those. So now I have 6 bromines and 6 bromines. Bromines balance. Aluminum's balance. How about potassium? Well, I have 1, 2, 3, 4, 5, 6. Over here I only have 1, 2. So I need 3 more boxes to get the potassiums to be in balance. That means I have to draw all the other things that are in that same compound. Okay, so potassiums are in balance, so let's check. Aluminum, 2 of those, and over here 2 of those. Bromines, I have 6. I have 6. Potassiums, I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now, how about sulfur? So sulfurs, I have 3. 1, 2, 3, and over here I have 1, 2, 3. Okay, now we're going to hold our breath and hope that oxygen's balanced. I have 12 oxygens over here. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They balance. Usually that happens, okay? You have some big scary looking element to balance. If you leave it to the end, it'll usually be in balance by the time you're done. So just count boxes. You have a 2 here. You have 1, 2, 3 here. You have 6 here. And you have 1 here. And there you go. That's how you do that for that compound. Look complicated. Turns out to not be so bad. So although I don't use the box method, I recommend you do. And it's a good way to get started. It's really, really the best way to get started. Okay? All right, here we go. Let's go to number 7. Just going to push ahead now. Okay. And we got number 7. It's going to be this. And this is called a combustion reaction. This is the most basic type of combustion reaction. It's methane or natural gas. Okay, this is methane. That's CH4. You burn it in oxygen, and that creates fire. You're gonna get a flame from that. It's going to produce carbon dioxide, which is not a poison, although you can't be in a room with nothing. It's what plants breathe. Okay, it is something that we have to have in our environment, and H2O, water, okay, which of course we have to have. All right, let's just draw our boxes. Okay, start anywhere you want with this. Generally, though, you avoid anything where the element appears more than once on the same side of the arrow. Here's the arrow right here. So avoid oxygen. You also avoid oxygen because you don't start generally with pure elements. You don't want to start with pure elements. And some of the equations we did earlier, you had to, because that's all there was. Okay, let's start with carbon. Well, carbon's already in balance, so we can't do anything. How about hydrogen? 1, 2, 3, 4, 1, 2. So we're going to put a 2 here. Okay. So now what? Our carbons are already in balance. Our hydrogens are in balance. So let's check our oxygens. Right here we have 1, 2, because it's 2 multiplies through. And actually, I'm sorry, I should have put my new box here. Okay. So now oxygens, hydrogens, I have 1, 2, 3, 4, 1, 2, 3, 4, carbon, 1 and 1. Oxygen on this side is 1, 2, 3, 4. On this side there's 2. So that means I have to add to the side I have the least. Okay, so now everything is in balance. So I have 1 CH4, 1 methane molecule, and then I have 4 oxygen. Excuse me. I have 2 oxygen, I'm sorry. 2 oxygen, 2 boxes. I'm counting the number of boxes. and then I have 1 carbon dioxide, and I have 2 boxes here for water. So it's 1, 2, 1, 2, and that's how you do that. All right, keep moving. Okay, here's another combustion reaction. It's a hydrocarbon called pentane. And you'll notice the reaction looks exactly the same, other than the hydrocarbon that's being used. But it's not going to balance the same. Okay, now let me get over here, and I seem to be having some focus problems here, so I'll do what I can with that, and hopefully it stays in focus while I'm writing. Okay, here we go. Okay, this time carbons are not in balance as they were in the previous problem. So I have 1 here, I have 3 here, so I'm going to add 2 more boxes. So now I have 3 carbons, 3 carbons. Hydrogens is next. Again, you want to stay away from pure elements or where they appear on the same side of the arrows in 2 different locations. That's complicated. So we're going to go to hydrogen next. So hydrogen, I have 2 hydrogens here, and I have 8 over here, so I need 4 more boxes to get those 2 to be equal. And if things work out the way they should, our oxygens should be in balance as well at this point. Okay, so we have 8 and 8 for hydrogen, 3 and 3 for carbon. So, well, not the oxygens are not yet in balance, excuse me. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 oxygens. I need to get this up to 10 oxygens, so I'm going to have to add some more boxes of 2 until I get that up to 10. So I have 10 oxygens everywhere. So everything looks good. I have 1 box here. I have 5 boxes here. I have 3 boxes here. And I have 4 boxes here, and I'm done. Again, use this method until you feel comfortable with balancing, and then you'll do it more intuitively. But I think it's a good place to start. Okay, I'm going to do this one the other way. You can do it the box method. It'll work, but you're going to draw a lot of boxes, a whole lot. So what I'm going to do is I'm going to simply do it my way. I get a C, an H, and an O. I have 8 here and 1 here. I have 18 here and I have 2 here. And then oxygens, I have 2 on this side. And watch this now. I have 2 here and 1 more there. So I have 3 on this side. Okay. All right. So where do we go with this? Well, we can start with carbon. It looks like the easiest to balance. There's 8 on this side, 1 on this side. So I'm going to make it this an 8. So now I have 8 carbons there, and I have 8 carbons there. Now what I also did was I added to my oxygens. I want to stay away from oxygen because until the very end, because if there's 2 of them there, 2 on the same side of the arrow, and it's a lone element there. I don't want to do those. So let's jump on over to hydrogen. So hydrogen. So hydrogen, I have 2 there, and I have 18 there. If I want those to balance, I need to multiply this by 9. 9 times 2 is 18. Okay, so I have 18, 18. Carbons are in balance. So let's see if, so our oxygens now are 8 times 2 is 16. Okay, be sure you follow that. 8 times 2 is 16. 9 times 1 is 9. So 16 plus 9 is 24. Excuse me, 23. Excuse me, it's 25. Sorry. 25. So 16 plus 9 is 25. Okay. So here's the trick. you've got 25 on this side. 8 times 2 is 16. 9 times 1 is 9. That adds up to 25. So I need this number to end up as 25 oxygen, but it's an odd number, and I have O2. So what I simply do is the coefficient becomes 25 over 2. In other words, if I multiply 25 over 2 by 2, I get 25. All right, so my coefficients are, as things stand right now, there's a 1 there. I haven't changed anything there. There's a 1 there. There's 25 over 2 there. There's 8 there. There's 9 there. So can you have a fraction coefficient? No. So what do? You multiply all the coefficients by 2. Okay, so I get 2 times 1 is 2. 2 times 25 over 2 is 25. 2 times 8 is 16. And 2 times 9 is 18. And that is that. Now the box method, if you like it, you can go ahead and use it. But notice you would have been drawing 25 boxes there and 16 boxes there. So in this case, I didn't want to use that method, even though I think it's a nice way to do things for simpler problems. But this one would have been really, it would have been crazy. You would have taken a whole page of paper to do it. All right? Okay, I'm going to do one more. I'm going to cut this assignment short. I want you to spend your whole week on this. So I tell you what, numbers 11 through 21 we'll do in class. If you do them at home, then you're that far ahead of everybody else, all right? But I'm going to do one more, and then we are going to call it a day. All right, so the next one, number 10, is iron chloride, sodium hydroxide, and that goes over to the arrow right there. Okay, I didn't leave myself space to write my coefficient, so I'm going to draw my arrow right there, and there's my coefficient. And finally, sodium chloride. Okay, so there we go. So there's the arrow right there, a little out of place for that. Okay, let's finish this one. Use whatever method you want, but I'm going to use the box method for you here. Now here's another one where you could have treated the OH like a single element, so you have one OH here and 3 OHs there, just kept them tied together. But I don't want to, if you're not comfortable with that, I don't want to do that right now. Let's just treat them like we said we were going to treat them. So I have 3 oxygens there, O, O, O. I have 3 hydrogens there. So let's just break them apart like that, okay? All right, and then over here we have sodium chloride. All right, what looks easy to balance? Again, there's no one place, but what would I stay away from? Nothing necessarily. There's nothing that appears more than once on this side. No element that appears more than once on this side. Doesn't really matter. Okay, so I'm going to, why not start with hydrogen? Doesn't matter. Okay, so I've got 1 there and 3 there, so I need to add 3 boxes here. All right, so hydrogens are in balance, and it also happens that oxygens are in balance, if you see that right there. Iron is already in balance, so let's go to chlorine. So chlorine, we have 3 here and 1 here, so we go to the side that has the least and add boxes. Okay. And let's see, so chlorine's 1, 2, 3, 1, 2, 3. Sodium, 1, 2, 3. We come over here, it's in balance. Hey, hey. Hydrogen, 1, 2, 3, 1, 2, 3. Oxygen, 1, 2, 3, 1, 2, 3, and iron 1 and 1. So it looks like we're good. So we have 1, 3, 1, and 3. And boom, we're done. Okay? I tell you what, I'm going to cut this right now because I'm going into tutoring. It's Saturday morning. I'll do the rest of them later today if you really want to work through these. They can be kind of fun after a while. They're kind of like little puzzles. So I'm going to stop at 10. I'll say that's all you have to have done by class. But if you want the rest, later today I'll put up the solutions for the rest of them. This video is already up to 50 minutes, or it's almost an hour. So we're going to cut it at this. So I'll see you in class on Monday.